I have the time right when everybody's lunch has settled in, right, and everybody's drinking a quart of coffee at this point. So I'll try to be as compelling as possible. I'm used to lecturing to the sleeping bodies of my students, so don't feel too bad if you're tired at this point in the afternoon. What I am going to talk about a little bit this afternoon for a couple minutes is just about buildings and their impacts on the environment, but also to talk a little bit about how buildings are beginning to respond to climate change in some of the different parts of the United States. So it's well known that buildings have a tremendous impact on our environment, producing about a third of the greenhouse gas emissions in the country, but also consuming about 70% of the total electricity in the United States. And buildings are really being looked at as a sector where we can begin to reduce our emissions to the climate in a significant way, getting into energy efficiency in buildings and green buildings. Notably, there's been a push in the last couple of years to create buildings that actually produce as much energy as they use over the course of the year, or produce as much water as they consume over the course of the year, so really that they begin to have no net impact on the environment. But while that's really important in terms of slowing climate change overall, and really something that we need to be focusing on, the kind of new threat that we're beginning to think about is how are these buildings going to be able to react to some of the expected changes in the climate. So when you think about the different parts of the United States where we have significant climate impacts, oftentimes you don't think of places like Binghamton, New York, which is not too far from where we are in Buffalo, New York, having major flooding events in the last couple of years, which have done a tremendous amount of damage. But how do we plan in critical facilities like hospitals to make sure that they're still able to operate in these types of situations? How do we think about communities and how they begin to respond to things like a storm surge or hurricanes that we have on the coast? I think everybody's really familiar with what happened the last couple of years with Hurricane Sandy and some of the devastation that brought to New York State, New Jersey, Connecticut as well. But then some of the less well thought out issues. This is my hometown. This is Buffalo, New York. This was Snowmageddon, Snowvember, Snowpocalypse. We had all the different kind of snow type of phrases for this. But things that we may not associate with a warming climate, things like having increased snowfall or having these kind of weird impacts in the wintertime, is certainly something that we're beginning to think about. So how do we think about climate change? How do we begin to address that in buildings? I think the really good thing is we already do think pretty heavily about how climate impacts buildings. For the most part in the United States, we're really fortunate to have a series of zoning codes that tell us where we're supposed to build or not to build, what kinds of properties are actually appropriate for those locations. We have building codes. We have some of the strictest building codes in the world to tell us how they begin to respond to things like different earthquake events or fires or those types of situations. If you think about it, being in a building in the United States, right now nobody's too concerned about what they would do if there was a fire in this building, how they get out of the space, or being protected in the space. We're really fortunate to have those codes and laws in place. And then we all have a series of standards, like ASHRAE standards, which govern things like indoor thermal comfort, ventilation, air quality, and spaces. And all three of these different levels of standards, codes, and zoning laws all kind of come together to make sure we have a protected indoor environment for people. What I was thinking about when I saw some of the presentations earlier, they were showing the range of the oriole, right, and how that's potentially going to change over time. And so Baltimore may no longer have those birds there. Buildings are actually the way that we have kind of been able to have the human range be all over North America and all over the world. That's our protective habitat that allows us to move in those environments. If we start to have changes in how those buildings and how those environments begin to respond, we want to adequately prepare in advance. So what kind of natural hazards are we talking about in the United States? There's 13 different ones that FEMA has actually identified as being of key importance and what people should begin to prepare for. I think the fortunate thing is in the buildings community, these are all things that we begin to think about and design for. Obviously, you can't really design for a volcano doing something to your building. At that point, you just want to stay out of the way of the volcano. But other things like earthquakes and fires are really dealt with as part of our codes in how we think about design. When you look at the list of those, though, the top 8 or so are all things that are expected to change with a warming climate. So making sure that we get the right data in place to begin to design in the right direction for those expected changes is pretty important. Now, out of all of these natural hazards, what do folks think is the most deadly to Americans. Which of these natural disasters actually kills more people each year than any other type of natural disasters? Man, you guys are like stealing stuff away. All right. You retain? All right. So with extreme heat, I just showed you a whole bunch of images that were kind of graphic to show you the kind of damage that goes to building structures. The next image I'm going to show you is equally as graphic for extreme heat, and thinking about what are the repercussions of what happens when we have these extreme heat waves. We have this kind of damage. Everybody's scanning it. No, there's no damage to the building at all. The damage is to the people that are inside those buildings. So in addition to talking about what we have in terms of vulnerable structures and vulnerable places in the United States, we have to think about the vulnerable people who may be living in some of these houses. Some of the projects I've been working on in Cleveland and Buffalo, New York, no worries, Cleveland and Buffalo, New York, right? We have extreme poverty in many parts of the city. We have buildings that may have been built to a code 80 or 90 years ago, but really haven't been updated since then. And in many cases, we have houses that are uninsulated or have physical holes in the roofs and the walls. So how do we begin to target resources to folks who may be the most vulnerable in those types of heat wave situations, in addition to other things like flooding or other types of natural hazards that we're worried about? One of the primary ways that we begin to target folks for extreme heat and also extreme cold, like we had in the Northeast this past winter, is through a program called the Weatherization Assistance Program. It's actually one of the largest rebuilding programs in the United States that provides services to low-income families for doing things like sealing homes so that you're not losing heat out of the envelope in the wintertime, and also providing insulation so that you begin to reduce utility bills. And when you start to look for some different types of houses, what that actually means in terms of their energy costs, for a low-income family, having a 45% energy savings is pretty significant. Having a $200 energy savings over the course of a year may not seem like much to a kind of a family that's in a higher income bracket, but in a lower income bracket, this can mean a tremendous amount. But when we look then to what this means, the last thing that I'm showing on the right, what it would mean in terms of installing an air conditioning system, that if you weatherize a home before you actually put in an air conditioning system, you could reduce the size of that system by half, has a lot of implications for the total management of the electrical grid and maybe preventing things like brownouts during those situations. Speaking of brownouts, a new term has kind of come up recently, which is called passive survivability. So how do buildings maintain adequate indoor environments in the absence of having electricity? In this case, this is trying to show that if you insulate the homes, the red images at the top are kind of the red lines at the top of the graph are kind of these uninsulated houses. So you can see on even a moderately hot day, something around 90 or 95 degrees, it actually can be over 105 degrees indoors. If you're doing the weatherization and making sure that windows can open in these older houses, in a place like Cleveland, Ohio, it actually has the potential to keep the temperature really within the comfort zone inside. And that's important to families, obviously, in the case of a brownout. But if you think about just operation of air conditioning systems, families may have that equipment, but not the money to actually run it. Another project we're working on, actually starting up in New York State, is to try to identify some of these different green building strategies, things like weatherization. How do we begin to work them into code and standards? We had a report that we did a couple of years ago that just identified 81 of these different strategies like weatherization. We're now going to spend the next couple of years to actually try to update that. So it's a very exciting time in terms of thinking about resilience in buildings, and we're really looking forward to digging into this a bit more. And like anybody who works at a university, we're really fortunate to have had funding and support from a lot of different agencies to make that happen. So with that said, I'm ending at exactly 10 minutes, and I'll turn it over. So thank you.